Welcome to our presentation on the flyweight design pattern. We will be presenting an overview of the design including its components, uses, and real-world applications.
Flyweight design pattern is a structural design pattern that aims to optimize memory usage by sharing common data among multiple objects. It focuses on dividing the object state into two parts, intrinsic and extrinsic. The intrinsic state is shared, immutable, and can be stored in a separate data structure, while the extrinsic state is externalized and passed to the objects when needed. By sharing the intrinsic state, the flyweight pattern reduces memory consumption and improves performance, especially when dealing with a large number of similar objects. Instead of creating a new object for each instance, the flyweight pattern objects are reused, eliminating the need for redundant data storage.
Alright, let's look at some of the components of the flyweight design pattern. We have the flyweight, the concrete flyweight, the flyweight factory, and the client. So the flyweight represents an interface that our concrete flyweights will adhere to, and it's the basis of all of our objects. The concrete flyweight is the implementation of the flyweight interface, responsible for defining intrinsic state, which is the shared properties that don't vary among the instances. The flyweight factory governs the creation and sharing of flyweight objects, ensuring that they are correctly allocated and efficiently used. And lastly, the client interacts with the flyweights. It stores and manipulates the extrinsic state, which is unique aspects that differ between instances, and it also ensures that the flyweights are applied and managed correctly in the given context.
Here are some situations in which you would want to use this design pattern. It can be useful in specific scenarios where you have a large number of objects that share common data and can benefit from memory optimization. The pattern is most effective when you need to create a significant number of objects that share common data. By sharing the data, you can reduce memory usage and improve performance. To safely share the data among multiple objects, it's best to ensure that the shared data is immutable. If your application is memory intensive and the creation of multiple objects is causing memory constraints, then the flyweight design pattern can help reduce memory consumption by sharing common data. There are also times when you should avoid the flyweight design pattern, and these include when the shared data needs to be modified individually by each object. Modifying the shared data may cause unexpected side effects for other objects sharing the same data. Also avoid this pattern if objects have substantial individual state that is not shared. In such cases, the benefits of sharing common data may be outweighed by the complexity of managing and coordinating the unique state. Ultimately, the decision to use a flyweight design pattern depends on the specific requirements, performance considerations, and trade-offs of your application. It's essential to carefully analyze your scenario and assess whether the benefits of memory optimization and object sharing outweigh the potential complexities introduced by this pattern.
The flyweight design pattern is most often used in the real world when optimization and efficiency are key. So some examples when this might be the case is in game design, in caching systems, in text editors, in graphics and multimedia systems, in network protocol implementations, and in symbol tables and compilers. Now, the reason you might need to have this efficiency is either you're performing complex calculations like with the caching systems or the network protocol implementations, but also it's very useful for more visual interfaces when graphics need to be rendered at a high speed, such as in game design or in graphics and multimedia systems.
Here is our list of sources for the presentation. Thank you for watching, and we hope you have gained a basic understanding about the structure and uses of the flyweight design pattern.